Good morning, I'm Jonathan Izett. I'm from the Delft University of Technology in the Netherlands. This is my poster where we looked at the fog occurrence at Schiphol Airport. So fog is obviously a hazard to airport operations. It affects aircraft movements, takeoffs, landings, and also ground movements at the airport and can cause significant delays. So efforts in the past have been made to try and mitigate fog at airports through very expensive and also dangerous measures, including putting lines of fire next to the runway to dissipate the fog. But what we found is actually that the conditions at Schiphol may already be less favorable for fog than the overall surroundings that we see. So this resulted from a wider analysis of fog in the Netherlands, where we looked at fog occurrence at different stations throughout the country, where we saw that Schiphol had less fog than its surroundings and then the rest of the country. So to look deeper at this, we looked at weather stations throughout the Schiphol network at the different runway systems, as well as 4 stations that are surrounding the airport around 20 kilometers away. And again, what we notice is that fog occurrence, so the fogginess observed, is significantly lower, particularly at the weather stations located right next to the terminal buildings, whereas stations further away have more than twice as much fog. Looking deeper, this is in part related to the local urbanization at the airport. We saw throughout the Netherlands as a whole, the more urban a station is, the less fog it has. And that's particularly true for our stations that are right next to the main terminal building, whereas the weather stations located at the further runway have much more fog occurrence. Another interesting feature we noticed is that airplanes are playing a role in modifying the local weather conditions next to the runways. So this is because as an airplane moves down the runway, the wake of its engine increases the turbulent mixing, which elevates near-surface temperatures by bringing warmer air from above, but also that the heat from the engine itself appears to play a role in influencing the temperature. So here's an example of a jumbo jet 747 taking off, and we see that temperature at 10 centimeters spikes by 3 to 4 degrees, and that spike lasts for a couple hours. We also notice that with multiple takeoffs that the cooling at the runway is delayed. So comparing 2 runways here, runway 18C and 18R, where 18R was the active runway at the time, we have much stronger near-surface cooling than we see at 18R until the last flight, and then the cooling also occurs. So this delay in cooling can also lead perhaps to a delay in fog. Work is still being done to try and understand this in greater detail. Right now we've only looked at 1 year of data, but it is very interesting, and it'd be very interesting to know if we also see this at other airports around the world.